Welcome students to this lecture series from Kalasilingam Academy of Research and Education. Department of Mathematics presents the course Complex Analysis with course code MAT 18R4026. This is block 1, unit 1.1. So this block or unit contains the following descriptions on definition of complex numbers, its geometrical representations, and analytic functions and polynomials. So we'll start with definition of complex numbers. So what is a complex number? A complex number is generally denoted as a plus bi. Here the plus is basically a separator between the two parts of a complex number. These two parts are namely known as real part and imaginary part. Here you can see a plus bi. Here a is the real part of the complex number, b is the imaginary part, and this plus is basically a separator between the real part and the imaginary part. This cannot be performed like what we do, like 2 plus 3 equal to 5 we can write, but a plus ib or a plus bi, this is not equal to some complex number, but the total representation of the complex number is a plus bi. Here I is the square root of -1. Okay, so this is how we write a complex number. Next slide, let me go to the next slide. Sorry. Yes, so now we would like to learn how to do the addition in complex numbers. When adding two complex numbers, we have to add it according to the real part and imaginary part. For example, I have displayed here this 3 plus 7i, it's a complex number, and 8 plus 11i, this is another complex number. So now this plus between these two complex number here, this is the addition which we are going to perform in the complex plane. So how to add these two complex number? We will do, as I said, we will do according to the real part and imaginary part. So the real part of the first complex number is 3 and the second one is 8. So we have to add these two. So 8 plus 3 turns out to be 11. And we'll write this separating plus here. This is plus. And again, the imaginary parts of these two complex numbers are respectively 7 and 11. So if we add these two, we will get 7 plus 11 equal to 18. So altogether, the final result of this addition becomes 11 plus 18i. Similarly, we can subtract also two complex numbers. How? I have displayed it here. We have taken two complex numbers. One is 5 plus 10i, and another one is 15 minus 2i. So again, we will do the operation according to the real parts and imaginary parts only. So the first real part here is 5, and the second complex number real part is 15. So 5 minus 15 turns out to be minus 10, and we have to do this operation also minus 2i in the second number. You can see that will turns out to be plus 2i. The first first imaginary part is 10, and the next imaginary part is minus 2. So 10 minus of 2, that is 10 plus 2, ultimately 12. So the resulting complex number is minus 10 plus 12i. Now, how to multiply complex numbers? This is our next concern. Okay, so again, I am giving an example over here. This is 3 minus 8 into I into 5 plus 7i. So here we can follow the algebraic rule of multiplication. So this is not real part into real part and imaginary part imaginary. Don't follow like this. So in this case, this multiplication can be followed as we do in our real number system only. So that will give, so first 3 into will be 5, so that is 15. Then 3 into 7i, that is 21i. Then minus 8i into 5, minus 40 into I. And lastly, minus 8i plus 7i. So ultimately it is 56 into I square. Now we will write it a little bit more. So we can see that this is equal to 15, and 21 minus 40i, 21i minus 40i, this will give you 19 into I. And as we know, I equal to root over of minus 1. So I square equal to minus 1. So 56 into I square will be plus 56 here. Now again, concluding all the addition, we will get 15 plus 56 equal to 71i minus 19i. So this is the resulting complex number, comes from multiplication of these two complex numbers, 3 minus 8i and 5 plus 7i. The next question is that how to divide two complex numbers. Okay, so division actually done through the complex conjugate. I'll be telling what is that. So first take this example, 7 plus 2i divided by 3 minus 5i. Now we have to know what we mean by what do we mean by complex conjugate. So the complex conjugate of the numerator, that is 3 minus, the denominator, that is 3 minus 5i, is 3 plus 5i. In general, we can say that complex conjugate of any complex number a plus ib will be a minus ib. So following that rule, we can say here the complex conjugate of 3 minus 5i will be 3 plus 5i. So we have to multiply the numerator and the denominator of the given division by complex conjugate of the denominator, that is 3 minus 5. Everything is displayed over here. So ultimately it becomes 7 plus 2i into 3 plus 5i divided by 3 minus 5i into 3 plus 5i. Now, so there are two multiplications. One is on the numerator, and another one is on the denominator. So we have to perform these two separately. So if we perform the multiplication on the numerator portion, that gives as 3 into 7, 21, 7 into 5i, that is equal to 35i, then 2i into 3, that turns out to be 6i, and 5i into 2i, that turns out to be 10i square, divided by 3 into 3, that is equal to 9, 3 into 5i, that is equal to 15i, minus 5i into 3, that becomes minus 15i, and finally minus 5i into plus 5i, that turns out to be 25 into I square. So performing all these, we get 21 and 35 plus 6 equal to 41. That's why I have written here 41i. And as we know already that I square equal to minus 1, so that becomes minus 10 here. And similarly, we can see 9 I have written just here in the denominator, and 15i minus 15i, that cancels each other, and 25 minus 25 I square, since I square equal to minus 1, we have written here plus 25. So ultimately it becomes 11 plus 41i divided by 34. So this is the final outcome of the division. So one thing I want to note here, as we can see, the complex conjugate of 3 minus 5i is equal to 3 plus 5i. Now, if we multiply a complex number with its conjugate, what will be the result? The result will be a real number. So how we can see there? 3 minus, in the denominator, we can see what we have got, 3 minus 5i into 3 plus 5i. So the ultimate result in the denominator is 9 plus 25 equal to 34. So in general, the rule is that suppose I have a plus ib as my complex number and I want to multiply the complex number with a minus ib. So a plus ib into a minus ib. So following the algebraic rule, we can write it as a square minus ib whole square. So that will be equal to a minus b square into I square. So that will be ultimately a square plus b square. Similar thing happened here. 3 minus 5i into 3 plus 5i. Ultimately, it is 3 square plus 5 square equal to 34. So that ultimately it's a real number. So in this particular unit, we have learned what we mean by complex number, how to add two complex numbers, how to subtract them, how to multiply and divide. So I have also given 4 examples, and I want you students to solve these 4 questions over here on your own, and we will see you in the next lecture video. Thank you.